Okay, so 2.4 deals with the imaginary unit, which is I. So imaginary numbers. 2.4. So the standard form for imaginary numbers is this a plus b times I. So a would be the real part, so we always add the real part first, plus the imaginary part. So we know that if we take the square root, we have the square root of -1, this is I. So this is our complex number, our imaginary number. So you guys have all seen this in Algebra 2, so this is not new. So like this would be the complex number, and the imaginary part is just the I. Yep, so the b would just be a number that's multiplied times the I. But since it's like being multiplied to the I, it's still part of the imaginary part, even though like we see here, 3 is a number, but since it's being multiplied times the I, it's an imaginary part of it. So this would be the imaginary part. And then this -5 would be the real part. Okay, so on the next slide, we just have the definition of a complex number. So if a and b are real numbers, then the number a plus bi is a complex number, and this is written in standard form. So on WebAssign, when you have a complex number, you're always going to put it in standard form. So you need to put that real part first and then the imaginary part second. So this is standard form. Okay, we're going to skip this slide. For this next one, it's the equality of complex numbers. So two complex numbers, a plus bi and c plus di, are written in standard form. If they're equal to each other, then we know that the real parts have to be equal to each other. So that would mean a and c are equal, and then the imaginary parts would have to be equal to each other. So if you have two complex numbers that are equal to each other, the real parts have to be the same and the imaginary parts have to be the same.
So that means you can't cross it, like if a was 1 and bi was 2 and then I, you can't add them?
No, you can't add like a real number with an imaginary number. They are.
But that's why you do the b equals d.
Well, this is just saying like if you had two complex numbers that were equal, the real parts have to be the same and the imaginary parts have to be the same, because you wouldn't be able to combine the two together.
Oh, okay.
All right, now we're going to look at some examples. So we kind of treat the I as if it were a variable, and we can't combine it with another term that doesn't have an I, but we could combine it with an I. So imagine if the I was just x. Like we couldn't combine x with a number, but we can combine an x term with another x term. So we can only combine like terms. So here we're adding the two together for a. So we have 3 minus I plus 2 plus 3i. So we add our real numbers together. So 3 plus 2 would be 5. And then we add our imaginary parts together. So we have negative I plus 3I, which would be positive 2I.
Miss Carver?
Yes. For the next one, we're subtracting it. So here we would distribute the minus. The first one we were just adding it so we could get rid of our parentheses. But now we need to distribute the minus sign. So we have 1 plus 2I minus 4 minus 2I. So we have 1 minus 4. We combine our real parts together. So this would be negative 3. And then we combine our imaginary parts together. So we have 2I minus 2I, which would just be 0. They cancel each other out. So our answer here would be negative 3. Any questions? All right, let's look at C.
And
The I all by itself
yeah,
is a negative square root. So remember how in the last section we said we couldn't have a negative under the square root because that would be an imaginary number? So now we're dealing with if we have a negative under the square root, we have an imaginary number.
okay.
All right, C. So here we have to distribute the negative. So we have 3 plus 2 minus 3I minus 5 plus I. So we need to combine our whole numbers together, our real numbers, and then we combine our imaginary numbers. So we have the real numbers, 3 plus 2, that would give us 5, and then 5 minus 5 would be 0. And so the real parts here cancel out. And then we look at our imaginary parts. We have negative 3I plus I, so what would that give us?
Negative 2I.
Negative 2I. For D, we have 3 plus 2I plus 4 minus I. Here we would need to distribute the negative. So this would be minus 7 minus I. So we combine our real numbers. So what do we get when we combine our real numbers together?
0.
0. So they cancel out. And then what do we get when we combine our imaginary numbers together?
0.
0. So our answer here would just be 0.
I squared equals 1, right?
Yep. I squared is equal to negative 1, because if we, which I was going to touch this on the next slide, but when we square both sides, I squared, the squared cancels out with the square root, so I squared would be negative 1, which we'll see this on the next slide in our examples. Ready for the next page? All right, so here we're multiplying. So for A, we need to distribute our 5 to both these terms. So we have negative 10 plus 15I. Can we simplify this?
You can divide by 5.
But if we divide by 5, we'd get the same thing that we started with, right? If we pulled out a 5.
Oh, right.
So we can't combine our real number and our complex number, so there's nothing else we can do, so this would be our answer.
And that's standard form.
Yep, this is standard form. So standard form always has the real part first and then the imaginary part second. For B, how would we multiply these two together? What do we need to do?
You'd FOIL it.
We would FOIL. So we multiply the first terms together and then the outsides. So that would give us 6i, and then the insides together, so minus 4i, and then the last terms, here we would have negative 3i squared. So we combine our like terms, so we have 8. 6i minus 4i would be positive 2i, and then minus 3i squared. When we get an I squared, we can simplify this because we said that I is equal to the square root of negative 1. When we square both sides, I squared becomes negative 1. So we know that I squared is negative 1, so we can substitute this I squared and plug in a negative 1 and make this a real number. So we have 8 plus 2i minus 3 times negative 1. So this would be 8 plus 2i plus 4, no, plus 3, because we're multiplying. Negative 3 times negative 1 would be positive 3. And then again, we combine our like terms, so we have 8 plus 3, this would be 11 plus 2i. Any questions on that one? All right, let's look at C. So for C, we need to FOIL. We multiply our first terms, 3 times 3 is 9. Then our outsides, negative 6i, our insides, positive 6i. And then our last terms, we would have negative 4i squared. So we combine our like terms. We have 9. Our 6, what happens to our 6i's? Negative 6i plus 6i.
They cancel out.
They cancel out. And then we have minus 4. What happens to our I squared?
It turns to negative 1.
It turns to negative 1. So this would be 9. Negative 4 times negative 1 is positive 4. So 9 plus 4 is 13. What do we need to do for D?
You distribute the 4i.
Perfect. We distribute the 4i. So what do we get when we distribute the 4i?
You get negative 4i plus
20i squared, right?
20i squared, yeah.
Perfect. So negative 4i stays the same because we don't have anything to combine that with. What happens to our I squared?
Turns to a negative 1.
Turns to a negative 1, so this would become minus 20. If this were WebAssign and we had to put it into standard form, we would put negative 20 minus 4i. All right, last one, e. What do we need to do here?
Before it.
We FOIL it. So this is like saying 3 plus 2i times 3 plus 2i. So multiply our first terms, our outsides, our insides, and then our last terms. So we have 9 plus 12i minus 4. We combine our whole numbers together, so we have 5 plus 12i. Any questions? We see that part C is complex conjugates, and that's why we ended up with a whole number for C. So when we multiply our complex number by its conjugate, we end up with a whole number. Yeah, before. Here we see that we multiply the two numbers by its conjugate. The middle ones cancel out, and all we have is a squared plus b squared.
Carver.
So let's look at some examples on the next slide. So we have 1 plus I, and we need to multiply it by its conjugate. So its conjugate would just be 1 minus I. So all we do is change the sign in the middle to the opposite sign. So here it's plus, we change it to minus. Everything else stays the same. All we do is change the sign in the middle. And now we just FOIL it out. So we have 1 times 1, which is 1. 1 times negative I is negative I times 1 is positive I. And I times negative I would be negative I squared. So this would be 1. Our i's in the middle cancel out. And then negative minus our I squared changes into a negative 1. So we have a minus negative 1, which would give us what? What is 1 minus negative 1?
1, which would be 2.
2. So this becomes a plus sign, so we get 2. Any questions?
Miss Carver, isn't there a rule?
So you can skip this whole step here of FOILing. You know that when you multiply by its conjugate, all you're doing is squaring each term. So if we go back to so we can just square each of these. Any questions? All right, next slide. We have the principal square root of a negative number. If a is a positive number, then the principal square root of the negative number, negative a, is defined as, so the square root of negative a is equal to the square root of a times I. This book puts the I behind the square root, but putting it in front of the square root, it's kind of easier to see that that I is not under the square root, so I always like to put it in front. So I think it's best to just put the I in front. On WebAssign, I think there's like 1 or 2 questions where it has like an I times the square root, and the answer has the I in front. So looking at the next slide, here it tells us that if we have the square root of negative 3, it becomes the square root of 3 times I, which I like to put it in front, so I would say it would be I times square root 3. Same thing with the square root of negative 12. They just take out the I, so they have I times the square root of 12. if we are multiplying square roots together, so here we're just multiplying all of these terms together, our I times I would be I squared. And then we can multiply the square root of 3 times the square root of 12. So this would be the square root of 3 times 12. What is I squared?
Negative 1.
-1. And then we can break down this 3 times 12 as 3 times 3 times 4. Since we have a pair of 3's, we can take out the pair of 3's. So we have -1 on the outside times 3. And then we have the square root of 4, which we know is 2. And then we have nothing under our square root, and then we just simplify. So our answer here would be -6.
Separated it.
Yeah, so under the square root, which if we wanted to, we could multiply 3 times 12, and that would give us 36. And then we know that the square root of 36 is 9. Or you could just break it down into the factors, and then just see if you have a pair of factors, you can take it out.
Okay. So the square root of 36 is just 6.
Yeah,
But since we have a negative on the outside,
it would be
put that
-6.
in.
Mhm.
Okay.
So if we're multiplying square roots, we can multiply them together. We can combine the terms. But if we are subtracting square roots, we can't combine them. So here we would just be left with I square root 48 minus I square root 27. We can simplify under the square roots, but we're going to skip that for now. I trust that you guys know how to simplify square roots. And then,
Simplifying of square roots. If we have like a number on the outside, do we combine that with the I?
yeah, so if you, all right, we'll look at the second term here. So if we have I square root 27, the square root of 27 would be 9 times 3. The square root of 9 is 3, so we would take out a 3. So we would have 3I times the square root of 3. So you don't really combine it with the I, but you multiply it times the I, because you can't combine the 3 and the I.
Yeah. Okay. Thank you.
You're welcome. Okay, and then in this last example, they just take out the negative from under the square root and put the I there. Oops. All right, let's move on to the next slide. So here we are solving. We have complex solutions of a quadratic equation. So for part A, what do we need to do to solve this equation?
Factor it.
We can factor it, but what would be easier to do?
-4.
Yeah, you can just -4 and then
We just subtract 4, get that to the other side, so we have x squared is equal to -4. And then what do?
you square root it.
Square root it. So we have x is equal to the square root of -4. How do we simplify the square root of -4?
That'd be 2I, right?
Awesome. The square root of 4 is 2, and then the square root of -1 is I. So we would get x is equal to 2I. And this would be plus or minus 2I. Because we get that plus or minus when we take the square root of 4.
Is it always going to be plus or minus?
Yeah. Yes. Okay. For B, we could factor this, which it factors, so it wouldn't give us a complex number, so this book, again, is not the best because we're dealing with complex solutions, and this is not a complex solution, so we are going to switch this 2 to a 4. So I'm just changing the example, so now we would have a complex solution. So I'm changing the 2 to a 4. Now this equation does not factor, so what do we do when it doesn't factor?
You use the quadratic formula.
We use the quadratic formula, so we have negative b plus or minus the square root of b squared minus 4ac over 2a. Our 3 is our a, our 4 is our b, and our 5 is our c, or negative 4 is our b. So negative b would become positive 4 plus or minus the square root. B squared would be negative 4 squared, which is 16, minus 4 times 3 times 5 over 2 times 3. So all I did was plug in our a, b, and c. And now we simplify. So we have 4 plus or minus the square root of 16 minus 4 times 3 times 5 would be what?
60.
60, awesome. Over 2 times 3, which is 6. So 4 plus or minus, what is 16 minus 60? 44. Negative 44. Over 6. How do we simplify the square root of negative 44?
You have 11 and 4.
We have 11 and 4.
Right?
And what else do we have under there? That we
And
can,
we have a pair of 2's for the 4.
okay, so we have,
So it becomes 4 plus or minus 2i square root of 11 over 6.
yes. So we can take out the negative, it becomes an I. We take out the 4, it becomes a 2. And then we're just left with square root 11, which instead of I times 2, we would write this as 2i. Over 6. And can we simplify it one step more?
Yes.
Can you do it by 2?
Yep, everything's divisible by 2, so we can,
So it doesn't matter what the denominator is, because I thought it only had to do with the denominator.
so if we have a common term in the numerator and in the denominator, we can pull it out. So here, this is divisible by 2, this is divisible by 2, and this is divisible by 2. So we can take a 2 out of everything.
What would happen if the 6 was a 7?
Then we wouldn't be able to simplify.
Okay.
So we have to have a
It's
common
only
term
if it has a common term.
in the numerator and in the denominator. But here we have like 2 numbers in the numerator, so they both have to have that common term. Like if the 2 was a 3, we wouldn't be able to take anything out. But here we can simplify everything by 2, so we have 2 plus or minus I square root 11 over 3. And this would be our complex solution.